Dear students, today we are going to discuss a new problem, that is mass attached to a pulley on inclined plane. So there are two masses you can see in this picture. There is mass m1 and mass m2. So this mass m2 is attached to the pulley, and further with the same string another mass m1 is attached and is placed on an inclined plane. Now we have to solve this problem and we have to write equation of motion for these, solving for acceleration or sometimes for tension T, right? So let's discuss this problem. Jumping into the problem, suppose this mass m1, it has weight m1g acting downward and normal reaction acting upward. So there will be R that acts, and this R makes angle theta with m1g. If you resolve this force m1g, so there is R acting upward, right? And there is a weight acting mg downward. So this angle theta, if you resolve m1g along in this direction, it will become m1g cos of theta, and to its 90 degree this will become m1g sin theta, right? Because we know if there is any force F making an angle theta, then if you take projection of this force, it will be F cos theta along the direction of the theta, and at 90 degree it will become F sin theta. Using this concept we will solve this problem. So m1g cos theta will act downward parallel to the direction of R, and m1g sin theta will act 90 degree to this force, right? Now since mass m1 and m2 are attached with the same string, so tension T will come, and we know when the mass is attached to the string, the tension comes towards the pulley, right? So this weight m2g acting downward. Now in all this situation we assume that acceleration is in this direction, that is m2 is moving downward. It means m2 is greater than m1. So once we know everything related to the problem, we can easily solve this equation of motion, right? So let us write equation of motion. Okay, first of all I will write for m2. So I'll write equation of motion. So it's easy, you know acceleration is acting downward. So from my previous concept and previous videos, m2g is dominating over t. So I can write m2g first minus t is equal to m2 into acceleration, this mass into acceleration. So this is my equation of motion for mass m2, right? Equation of motion for mass m1. So for m1, it's again you have to see this R is balancing m1g cos theta. So R is equal to m1g cos theta. Please keep it in mind, this R is not at certain angle. So while making the diagram I may have made the mistake. So try to assume that this is a straight line. m1g is cos theta is exactly acting downward in the same direction as of R, right? Now R is equal to m1g cos theta, we know from here, and for writing equation of motion for m1 we will get, so acceleration is upward, this t is dominating over m1g sin theta. So we'll write t first minus m1g sin theta is equal to mass into acceleration. This is my second equation of motion, and this is another equation of motion. Now using 1, 2 and 3 you can solve for t and acceleration a. So if a is given to you, you can solve t, or whatever is required. Using these equations you can solve the whole problem related to the inclined planes. So this is all about the inclined plane. I hope this video is informative and helps you to solve all the problems related to the inclined planes. Thank you so much.